Question 7. The diagram shows a horizontal table on which a mass of 4 kilograms is placed. Masses of 10 kilograms and 1 kilograms hang over the sides by means of a string which passes over smooth pulleys. Find in terms of g the common acceleration of the masses if the table is smooth and if the table is rough. Okay, so initially we're going to look at again the three masses. So we have the 1 kilogram mass, 4 kilogram mass and the 10 kilogram mass. Okay, in the 1 kilogram mass, again remember acceleration is going from the lowest weight to the highest weight, so it's going to be going that way. So we're going in a clockwise direction again. So force is mass times acceleration, so that's 1 times g. Force is also going to be T1 pulling it up and 1g pulling it down. So I now can say that A is equal to T1 minus G, so A plus G is equal to T1. Moving over to the other side, let's look at this. Force is mass times acceleration. It's moving down this time, so force is 10A, and it's also 10G minus T2. I can put those two equal to each other, and I get T2 is equal to 10G minus 10A. Now I'm going to look in the middle here. I have my 4 kilogram weight in the middle, or mass in the middle. T1 is going that way, T2 is moving that way. Friction is going opposite to movement, so it's going to be going that way. Okay, so I can say from this the friction is equal to 0. So that means the forces are going to be T2 minus T1, or force is equal to mass times acceleration, so that's 4A. So I can say that 4A is equal to T2 minus T1. I write this down. I sub in A plus G for T1, 10G minus 10A for T2, and I solve it to get A is equal to 9 over 15G. So that's for part 1. The table is smooth and there is no friction. If the table is rough and there's a coefficient of friction that is a half. Well, if the coefficient of friction is a half, the normal for this mass is going to be 4g. So the friction is going to be mu times r, so that's a half times 4g, so it's 2g. So that means that this line here actually becomes T2 minus T1 minus friction. So that's 10g minus 10a minus g minus a minus our friction, which is 2g, and the acceleration is 7 over 15g.